Hello guys, so today I'll be solving this problem. So the problem name is count the number of computer unlocking permutations. Okay. So the problem states that we have been given n computers. So let's call it C1, C2, C3 up to some Cn. Okay. Then so we need to decrypt all the computers from starting from second index to nth index. Okay, and the password for the first computer is already decrypted. Okay, so this guy is already decrypted. Okay, now yeah, all other computers must be unlocked using it and another previously unlocked computer following this information. So there is some rule, so by which we can decrypt other computers. So the first rule is, so if I have a ith computer, okay, and let's say I have a jth computer, okay, where j is less than I, you can see in the number line. Okay, so if this guy's complexity, okay, c of j is less than c of I, okay, then I can decrypt my ith computer. Okay, so then the second condition is, again, if I have a cjth computer, okay, and I have a cith computer, okay, so if this guy is already unlocked, okay, then I can use this guy to decrypt this. Okay, cool. So these are the two rules. Then we need to figure out the number of permutations, okay, number of permutations that represent a valid order in which computers can be unlocked. Okay, starting from the computer 0 as the only initial unlocked one. Okay, so number of permutations of valid moves, you can say. Okay, cool. So this is the problem statement. Okay, and yeah, finally we just need to return the answer in modulo x, because there can be multiple ways to do it and it can overflow our integer data type. So yeah, so so this problem is not that difficult. Okay, so if I will rate it like code forces uh, a time pro a like problem a problem, and that to be like division 2. Okay, with a rating of maybe 800 to 1000. Yeah, maybe, yeah, because if you go through all this problem statement and you run your own some test cases, you will easily get the pattern. Okay, and the code for this is pretty simple. Okay, so let's run some test cases actually. Okay, so let's say test case 1. Okay, so let's say this is my index and this is my complexity. Okay, cool. Let's say 1 2 3 4. Okay, let's say I have been given this array. Okay, if I put the indices 0 1 2 3. Okay, so as per the problem statement, this guy is already decrypted. Okay, now I can use the second rule, okay, to decrypt this guy, because if you look at the indices, okay, 1 is greater than 0 and the complexity of the like the one index computer is lesser than my complexity of my first element, right? And as per problem 2, if this guy is unlocked, okay, if jth index computer is unlocked and j is less than I, okay, so I can unlock or decrypt the password for the ith computer. So using that I can decrypt this guy. Okay, similarly I can use this computer to decrypt this guy also. Okay, and yeah, finally I can use the same guy to decrypt this guy also. Okay, so if I look at, so this can be a valid move. So 1 2 3 4. Okay, so this is the order of decryption. Okay, then another way will be like, let's say I go with again 2, but this time I did 4 first, then 3. Okay, this is also a valid permutation. Okay, then another way will be, let's say I unlocked 3 first. Okay, then I did 2 and 4. Okay, another will be, let's say 3 first, then I will just switch to these two values. Okay, then another permutation will be, let's say I did 4 first, then 2 3. Okay, and then final permutation will be 4 3 2. Cool. So these are all my permutation. Okay, because I have this guy, okay, by which I can unlock rest of my computers, right? Okay, so the number of like the rest of my computers is 3. Okay, that means I have 3 places to place 3 things, which is like 3 factorial ways to do it, right? So if I say it in a generic sense, okay, so if my first computer itself, okay, has the minimum complexity, okay, in the rest of among the rest of my computers, then that means I can use this guy to unlock everyone, right? So the number of uh, the rest of my computers will be n minus 1. Okay, that means n minus 1 factorial ways, n minus 1 factorial ways will be my answer. Cool. So this I got from test case 1. Okay, then let's go for a test case 2. Okay, so let's say again index complexity. Okay, so let's say I have maybe 2 here, 9 here, 2 here, and 1 here. Okay, so these are my indexes. Cool. So let's look at this test case. Okay, so my first computer complexity is 2 and it is already decrypted. Okay, so using this I can decrypt this guy because this guy has a higher complexity and it is higher in the index value. Okay, but can I decrypt this guy? No, because as per the problem statement, okay, the or the rule 2, okay, so the complexity of CI CJ should be strictly less than the complexity of my ith computer. Okay, but in this scenario the complexities are same, and that means I cannot decrypt this guy at all. Okay, similarly let's look at this guy. This guy has a complexity of 1 and I do not have any indices where the complexity values are less than 1. Cool. So then that means this guy also cannot be decrypted. So here, since all computers cannot be decrypted at all, okay, so the answer will be 0. So from this, what we can infer? We can infer that the minimum value or the minimum complexity, okay, of a computer should be my root computer or the 0th index value of my complexity array. Okay, so min c should be present in my complexity of 0. Okay, then the second condition that we look is like the minimum complexity, okay, uh, it should have a frequency of 1 only. Okay, so in this scenario only, right? So when I'm considering this guy, okay, as my minimum complexity, when I'm getting the same complexity computer here, okay, I cannot decrypt them, right? Because they are not strictly lesser than, they are equal to themselves. Cool. So these are my two conditions. Okay, so whenever I have these two conditions, then that means the answer is always 0. Okay, but is there another test case, okay, where we are getting some different answer? Okay, so let's look at maybe this case, 1 to 11 19. Okay, so this is similar to our first test case only, right? Because if this guy, this guy is the minimum here, right, which means I can generate all permutations, okay, using these 3 computers because all of them are lesser than this. Okay, and if you have any thought like maybe there is a way when I'm unlocking this, okay, and then I'm looking at these values, okay, those ways are already covered in this scenario when I'm considering this guy. Okay, so then that means the minimum computer needs to be at the first index. Okay, now if the frequency of my minimum computer, okay, is 1, then that means I can generate n minus 1 factorial ways of my valid order in which the computer can be unlocked. Cool. So yeah, that's the idea. So yeah, I'll just code it up in maybe C++, then you guys will have better clarity. Okay. So yeah, so let's start with modulo. So I'll say modulo int that to be, oopsie, 1 9 plus 7. Then I will initialize my answer to long maybe. Okay, I'm using long because it might like integer overflow, so long will capture that, and after doing a modulo, so it will again fall back to integer range. So yeah, for that only. Okay, then my first guy is already unlocked. Okay, so I'll simply calculate the factorial in my for loop, as well as I will check whether the first computer, okay, is my minimum index, and the frequency of that should be 1. Okay, so I'll start with index 1, and from that I will go with I plus plus. Okay, so I'll say answer equal to answer times I, and I will do a mod. Okay, so this thing will give me n minus 1 mod factorial. Okay, because here if you look at the iteration, this will go like 1, then times 2 times 3 up to n minus 1. Okay, which is nothing than n minus 1 factorial. Cool. Then I'll check. So if my and I will rename this to array. Okay, complexity is a very big name. Okay, so or maybe C. Okay, if C of I. Okay, so if I have a ith computer which has a complexity. Okay, oopsie. Yeah, so if I have a ith computer which has a complexity less than, okay, which is this scenario, or equal to, which is this scenario, okay, equal to my first computer, then that means I cannot decrypt this guy. Okay, because this guy is not strictly greater than my first computer. So I'll simply return 0 from here. Okay, and I will return answer in the end. Let's run it for all test cases. Ha, error. Cool. So because I haven't stored n here, so I'll say c dot size. Cool. Now let's run it for all test cases. It passed. Cool. So what I did is, so when I solved this problem, okay, so I simply ran some test cases, and from that I got this pattern. Okay, and I simply coded up. So yeah, that's the idea. Now let's do it for Golang. So yeah, I need to capture n first. I will not do that mistake again, so I'll say C. Okay, then I'll declare my ans, so I'll say ans 0. Then oh no, I will initialize to ans 1. Okay, because I'm doing multiplication. Then I will iterate over my elements starting from the first index, then to n, then I plus plus. Okay, I'll say I need the modulus. Yep, mod. Yeah, I'll say mod 997. Yeah, but this guy will be in float, so I'll say int, and I will say const. Cool. Yep. Oh yeah, where? Cool. Then the same thing what we did in C++. So I'll do a mod here. Then I'll check if C of I is less than equal to C of 0. Then that means I will simply return 0 because I cannot decrypt that computer. Okay. Then I will return ans. I'm running for test cases. It's taking time, and it passed. Let's submit. Cool. Now finally let's do it for Rust. So I'll capture n first. Okay, and again C. Okay, c dot len. Then I'll create a mutable variable for my ans. I'll initialize to 1. Then I will create my mod. I'll say 1000000 with a 7. Okay, cool. Then I will iterate over my complexities. So for I in 1 to n, okay, I'll say ans equal to ans times I. I'll do a mod here. Okay, then I will check if C of I is less than equal to C of j. Then I will return 0. Okay, and then finally I will return uns. Cool. Submit. Okay. Oh, mismatch. Okay, because I'm multiplying it with the u size, or the compiler thinks this should be of u size. So what I can do is I'll simply return as i32. All test gets passed. Now let's submit. And voila, it passed. Cool. So this was the idea. So the problem is not much a bigger deal. So because if you run some test cases, you will already get the you will get the pattern, and then you can easily code it. And if you see, it's only like 14 lines of code, again based on your coding, so you can less this, you can reduce the size of your code. Cool. So that was the idea. So if you like this explanation, please do subscribe to the channel and put a like, or maybe you can comment there. So yeah, please do comment if you guys have any doubt, because from that I will know where I'm lacking in the explanation. Okay, and I will improve on that, right? Cool. So just stay tuned to watch more videos. Bye bye.